Welcome to the AWS Summit Online for the Americas. My name is Eric Johnson. I'm a Senior Developer Advocate for Serverless at AWS. But today we're not going to be talking about just serverless. We're going to be talking about containers and serverless. In fact, we're going to be talking about using containers and serverless to accelerate modern application development. Modern application development. How do we define that? If you were to put 100 people in a room, you might get 100 different definitions. How we look at that is kind of how AWS or Amazon in specific went from monolithic applications to microservice applications and the tools that were used and the approaches that were used. So we're going to talk about that just a little bit. So let's jump in. As I said, Amazon moved from monolithic to microservice applications to help speed up and be more agile in our production. And this wasn't just a change in our architecture, it was also a change in the way we designed our teams and the way we work together. So this is where we came up with this idea, and you've probably heard of it, of the two-pizza team. Now, a two-pizza team, the idea behind it is it's a team the size that 2 pizzas can feed. Now, I like to say that I myself am a two-pizza team, but you get the idea, right? So with two-pizza teams, the teams themselves have full ownership and autonomy of the part of the application that they're building or their application. Kind of this you build it, you run it idea. And so with that, we've kind of removed all the red tape, all the stakeholders, and the things that delay us from pushing code out. And it allows our teams to focus on innovation, which is what really makes it different. But the issue here is what we find is the teams were solving for the same problems, right? They were solving for storage or queuing or pub sub and things like that. And so we had a lot of different solutions going on. So what we found is we really needed to kind of solve it once and then reuse it. And so this idea is to build building blocks that are reusable with the teams. Now there's a couple of reasons why you would build building blocks. One is to reduce work. Once you solved a problem, once you've got that running, don't redo it. So for example, S3 storage. S3 storage provides a great way to do object level storage and allows us to use that among the teams so we're not resolving that. The same with queuing with SQS or pub sub with SNS. The second reason that we would do this is to solve difficult problems, right? And again, once you solve it, you don't want to redo it. And I'm talking things like, so these are really tough problems like networking or, massively scalable global databases like DynamoDB. So once we've solved that, we're able to use building blocks that each of the teams can take part of that. And so the building blocks allow us to package the best practices in a reusable format. Teams are able to pick and choose what they want. They can say, I need this, but I don't need this. And the benefit from this is the combined experience of the entire organization. So what we've done at AWS is we've said, hey, we're going to make it our mission in finding the best way to bring these building blocks to our customers. So we're going to be talking about that today. So here's what our agenda is going to look like. We kind of break this into 3 different areas. The first is software delivery. And how we deliver software influences almost all of the culture, process, and technical changes that we implement, right? As developers, we want to be agile. As teams, we want to be agile. And agility comes from standardizing deployments, simplifying deployments, and automating deployments. The second area we're going to talk about is our operational model and what we at AWS have done to simplify operational tasks on our side of the shared responsibility model. Now, if you don't know what the shared responsibility model is, don't worry, we'll talk about it in a few. I'll walk you through it. And the last area we're going to cover is application patterns. And application patterns really affect how we choose the building blocks that we're going to use. What patterns are we using? What blocks do we need? So let's jump in. Like I said, at Amazon, one of the quick lessons we learned is that we can't have a single deployment pipeline for our entire application. So instead, we moved to a pipeline per team. And even that has begun to migrate and change as well. And so how each team deploys has gone through an evolution. And let's talk about that evolution. So even with automated deployment, there are multiple ways to view an application update, right? Replace the old with the new, so we could swap out the old and put the new in with a little bit of downtime. Or maybe you're going to do a blue-green where you bring up a new one and then you switch over. But what we want to do is we have this thing we call fractional deployment. Okay, where you can put out just a little bit of the deployment at a time. And that's where our teams are moving to. What our teams are doing is they're saying, we're going to put out just a little bit of the code and put a little bit of traffic to it and try it out. And we're going to wrap it with metrics. We're going to wrap it with testing. We're going to put eyes on screen. We're going to do all kinds of things to make sure that code is working. And if it's working, then we're going to add a little more traffic to that and a little more until eventually all of our traffic is going to the new code. Now, if it fails, then, obviously we're not going to deploy it and we're going to roll back. So to help us do this, we kind of changed the way we package our applications. In the old days, applications and infrastructure were separate, right? And usually on separate teams. And so you really ran a higher risk of incompatibility with dependencies or hardware. And this is really why containers kind of came around and became very popular, because a developer could say, hey, that worked on my desk and it's the same environment going throughout the pipeline. With serverless, we take this a step further. For your application your infrastructure is your application. Those are combined all in one. And so what this allows is a common code review process, and where that's all together and it's deployed as a single application. And we call this application first deployment. So just if you get that idea, we're going to package that all up, and here's the package, and we're going to drive that by the application. So let's jump into the operational model and the changes. We've covered kind of the software deployment. Building blocks, like we've been talking about, can introduce some complexity. Let me tell you what I mean by that. While we love the idea of building blocks and we can say, hey, you can use this is solved, this is solved, this is solved, this is solved, and you can pick which ones you want, what ends up happening is there's a lot of different moving parts, right? We have a lot of different pieces that you can take advantage of. In AWS alone, we have over 200 plus services in our dashboard. So we want to help developers remove that complexity. And so we asked ourselves, what do developers need to build and run applications? And here's what the developers are telling us. They're saying, number one, we build applications, not infrastructure. Okay, so we don't want to worry about maintaining infrastructure, patching OS, things like that. We want you to do that. And we say, okay, we're glad to do that. Number two, we want to scale quickly and seamlessly. And that means that when my application is running it and load hits it, I want that application to be able to handle that load, and I want it to scale up quickly and be elastic and scale down quickly as needed. And they tell us, we don't want to manage that. We don't want to wrestle with that. We want you to handle that for us. And finally, we want security and isolation by design. Now, let me explain what that means. Now, I'm a developer. Some would argue that, but I am a developer. And as I develop, and I'm guilty of this, I know you're not guilty of this, but I am. I'll get an application running, it's humming along, it's optimized, it does all the cool things, and then I go, I should add some security to that. I should add login. I should add least privileges. I should be wrapping that with identity and access management, whatever. And it tends to be, dare I say, an afterthought. And what developers are telling us is they don't want security to be an afterthought. They want it to be ingrained and built in from the beginning. So one of the things we did, and this was about a year and a half ago at reInvent 2018, we released something called Firecracker. And this is one of the places where we had key innovations for security and isolation, right? Firecracker is an open source virtualization technology that is purpose built for creating and managing secure, multi-tenant, isolated function-based services. And so it enables services like Lambda and Fargate to improve resource utilization and overall customer experience. So it's just one of the examples. You can also add Nitro and Amazon Linux 2, where we're diving deep into the infrastructure, into the hardware to help customers run faster, more efficiently, and more securely. Okay, before we step into the other ones, I want to visit the responsibility model. And I referred to this in the beginning, but we're going to kind of look at this real quick. So if you think about the responsibility model, it's a line that divides the responsibilities that we have and that you as developers have, right? And so we cover, this is part of the shared responsibility model. And some customers want to have lots of knobs and levers, and they want to manage everything. They want control. But other customers say, look, we don't want anything. We just want to worry about code, and we want you to worry about handling the elasticity, the scalability, the security, the redundancy, those things like that. And so at Amazon, our goal is to provide choices, right? To help you provide, or to provide you choices that you can say, I want all the control, I want you to have all the control, but we also want to be continually moving that line so that for those who want it, less and less management is required, where Amazon just really controls under that line, and we move that line continually up. However, sometimes choice can be a trap, right? If we think about this, and have you ever heard of this, the paralysis of analysis? I love that term, where sometimes we can have so much to choose from that we kind of get the deer in the headlights and we don't know where to go from that. And this is one area where I see when we talk about clusters and cluster management for containers. With cluster management, when we sit down and talk with folks about how to do the containers, it automatically comes to how do we manage the cluster? What are we going to do? Do we do one cluster with a lot of apps? Do we do a bunch of clusters with a lot of single apps? What's an instance going to look like? And it really becomes quite complex, right? And you think about EC2. When you were using EC2, you didn't care what rack your VM came up on. You didn't care what machine your VM was in. You just cared that your VM came up. And so with containers, we kind of want to step backwards, and we added complexity. And I love this. Cluster management systems, I don't love this, but I love the statement, says it adds significant amount of accidental complexity. Okay? Containers kind of brought back this, and it's almost a regression where we said, customers have to think about capacity again. They have to think about these kind of things, and this is a problem. And so we've added significant amounts of accidental complexity to our arrangements. So let's look at, when I say accidental complexity, let's look at what that means. Now, complexity in general is something as developers we deal with often. But there are different types of complexity, right? There's essential complexity, which this complexity is regardless of the experience, the tools, the latest platforms, etc. I'm going to have to deal with this complexity. This is what solves the problem, okay? But accidental complexity is complexity that really doesn't matter, but we've kind of brought it in with us, or we've kind of been saddled with it, where someone above us has said, look, use this or do it this way, and that's more complex. And so Amazon is striving to bring accidental complexity as close to zero as possible, right? So one of the ways we're doing it is the complexity of capacity in management for containers. We believe that capacity management, the best way for capacity management is through serverless. With Fargate and Lambda, you have no pets. There's no decision around packing applications onto nodes. There's no decision on number of nodes in a cluster or how to set up the cluster for each team. Right? There's no optimal placement strategy. You just say, here's my code and I want it to run, and then you deal with the capacity, right? But let's talk about the reality of a customer's journey to containers, right? I know that probably you listening, you're on Fargate, your service already, but in reality, most journeys don't start that way. A lot of folks are still running applications on EC2 instances. Not anybody here, I'm sure, but some people are, right? And so what happens is when they want to make this journey to containers, it usually starts with writing a brand new application or migrating an application from EC2 to something like ECS, right? But the thing about that is you still, even so, you still have EC2 instances to choose. You still have to do some capacity management, right? However, we know that some people go right to Fargate. In fact, 40% of customers who use containers start with Fargate. So here's the struggle. People are still trying to decide which should I choose. And they're not sure, so they're making this choice very early in the game. But the reality is they'd rather these decisions become late binding decisions, meaning they want the application to drive which model of capacity management we're going to use. And so they challenged us to make it easier for them and let the application guide the infrastructure. So welcome to application first decision making with Amazon ECS capacity providers. All right, this was released at reInvent last year, and it's yet another abstraction that shifts the operational model from you to us so that we can take on that. And here's how it works. So you can pick two types of capacity providers. In this instance, we're choosing auto scaling and Fargate. right? And in either, you can actually you can declare how much of your capacity should be using Spot. And Spot is, you can use Spot instances with Fargate now. That was also released at reInvent 2019, and then also with EC2. So I can come in and say, hey, I'm going to have Fargate and I'm going to have auto scaling as my providers. And in there, I want 30% of my Fargate to be on Spot, and I want 40% of mine to be on or 40% of my EC2 to be on Spot as well. So you have a lot of flexibility here. And then looking forward, you can kind of see the potential that's going on here as we start to make more of this available. Some of this isn't available yet, but looking forward, you would be able to start an EC2, then you can move to Fargate, and then you can declare some Spot instances. And then you can use POS providers that are in the works, like ECS for Outpost or Wavelength or Local Zone. So what we've done is we've brought that capacity management back to our problem, right? Not your problem. And that's removing some of the accidental complexity. Another way we removed accidental complexity is ECS Fargate support for Amazon ECS. So rather than you trying to deal with syncing data in clusters and remounting volumes, you can actually use Amazon Elastic File System. Amazon Elastic File System is a fully managed Elastic NFS file system for use with AWS Cloud Services and on-premise resources. And it's built to scale on demand to petabytes without disrupting applications. And it grows and shrinks automatically as you use it. So it takes that away. And while it's not on this slide because it was just released, we are also offering this for Lambda. So you think about it, if I can have Lambda connected to this, some of my applications running on containers, some of mine is running in serverless with Lambda, and we can connect to the same data. So what about EKS? So we've talked a lot about ECS and some of the things that we've done there. But with the EKS, we've also seen some changes. EKS is now available with Fargate, right? As of reInvent 2019, EKS customers can now enjoy the same benefits that ECS does with Fargate. And that's, it's removing the need to provision and manage infrastructure for pods. It's right-sizing server utilization and cost for each pod, and it's providing strong security isolations for every pod by design. So with that, you're getting that same kind of power that you get with ECS. So let's go back to our operational, our operations here and look at this. And you can kind of see the change in these. So if we start at the bottom and go up, with the Amazon EC2, the way we kind of talk about this is in our shared responsibility with Amazon EC2, AWS is going to handle the underlying infrastructure, the data centers, the security, things like that. But the customer is responsible for everything else, the application code, data source integrations, management tasks, things like that. But if we move that up a stack and we go to ECS or EKS, then AWS is going to handle the container orchestration control plane, and then the underlying infrastructure. And the customer, you're doing everything else. With AWS Fargate, we're starting to see a pretty good shift, right? So with AWS is going to handle the orchestration, the scaling, host OS, and the underlying infrastructure, and then the rest would go to the customer. However, with Lambda or serverless, we kind of do this whole flip-flop, right? And so with Lambda serverless, the customer manages the application code. That's what differentiates you, and AWS does everything else. So you see how we've kind of slid that up the stack. All right, so far we've been talking about containers and kind of this gradual migration to serverless. So let's look at serverless and some of the work that we've done in the operational controls to help you as a customer innovate faster. So first thing is we've improved VPC performance. So previous to this, it used to be that if you were running a Lambda inside of a VPC, it had a slower cold start time than a regular Lambda function. And since then, we have created a VPC to VPC NAT that's created when the Lambda is either created or updated. And so no longer at invocation is the connection being made. It's done when we create the Lambda, so it's already there. And this does two things. Number one, it makes for a faster cold start time in VPC. In fact, outside and inside should look the same. Number two, it reduces the amount of IP addresses being used in the network. The second thing we did is we added controls for stream processing. Now, as much as we'd like to come out and say, look, we know all the things about your application, we will make all the decisions, we're well aware that where it comes to your application, customers know best. We're going to help you manage everything we can, but there are some decisions that you want to make, and there's some knobs and levers. So a couple that we've added back in, or not back in, but we've added are batch windows and parallelization with Kinesis streams, right? So what this allows you to do with the batch windows, you can say, let's say, I don't have a lot of data flowing into Kinesis, and instead of it having to reach a certain point before it'll process, it has to have a certain load. I can set a window and say, look, just wait 10 minutes, then go, whether you have 2 or 20 events. And with parallelization, I'm able to add other lambdas or split it out into multiple lambdas that run in parallel without having to shard. And you can add things like you can set the max age, you can bisect these. The last thing we did is we added async function destinations. Now, what this means is we know that with async functions, it's kind of this fire and forget idea. And we say, okay, go ahead and fire that and then forget about it. But if the async function dies, what happens? So we know that you need to be able to go, hey, what happened there? So we added destinations where we can say, if it fails, do this. If it's successful, do this. You don't have to choose both. You can use just the fail scenario or just the success scenario. So it allows you to kind of keep that system operating, even if there's a fail in the code or a fail in the service. All right, so sometimes you need more knobs, right? And so we know that with super latency sensitive applications, cold starts just can't be a thing. They have to be completely gone. So with that, we've created Lambda provision concurrency. And this allows consistent double-digit latency, so very minimal latency, but it's very dynamic on how you can set it, right? So you can set it auto-scaling for it, you can do manual provision, you can add burstability to it. And we really consider this a finer grain control that you can balance with your cost and really say, you can kind of balance, do I need that low cost, or do I need that low latency, or can I balance that out a little bit? So you have a lot of control and really you just pay for the value of what you're using. And the fun thing about that is it is still serverless. All right, so our goal from the operational model perspective is heavily focused on developer productivity. We can make it. We ask ourselves, how can we make it easier for you to run your applications without worrying about the infrastructure detail? The analogy I would use for this is really a number of gears. You're driving a car, you've got multiple gears, and the idea here is you could choose a low gear, and I want to control everything, and I want to turn all the knobs and levers. I want to have full management. You have that, or you can go in a high gear and say, look, we're gonna run crazy and go forward, and we want to innovate, and we'll let you handle all that. But you have the choice, but the option is to push as much of that operational responsibility off to us as you can. So let's talk about application patterns. Now, when we think about application patterns, we're really thinking about this idea of how applications communicate. And one of the architectural patterns that has been prevalent and successful since the earliest days of the internet is small pieces loosely joined. Okay, it's small independent services that are loosely joined that can combine to make larger things. And they allow change in small chunks that limit the blast radius of the changes you're making. And innovating in small chunks allows you to innovate faster, but on a lot of different fronts. And we think that there are 3 core architectures or patterns that support this. And that's API-driven architecture, event-driven architecture, and data streams. So an API is the front door of a microservice. And its job is it guarantees the contract, right? So here's the contract, here's what I need, here's what you'll get, and behind the door, we don't care what happens. And that's really the idea that we do when we talk about our 2 pizza teams at AWS. When we talk about them, we often make a hardened API a requirement of any new team, using APIs to define stable contracts between the services. So looking at Lambda, looking at Fargate, they have a perimeter API that when you want to talk to them, that contract is set and the team can innovate and work inside without changing that. The tool we use and the tool we offer to customers is API Gateway. It's a very powerful tool that allows you to build these contracts, allows you to build these front doors for your applications, but it also allows you to roll off a lot of things that you would have in your code to be handled at API Gateway. For instance, authentication security. API Gateway works nicely with Cognito. It can also work with third parties like OAuth. It works with identity and access management, as well as web application firewall to secure your application and granularly as well. Then you can add, features like caching, throttling, custom domains, analytics. We tie in closely with access logs, where you can dump directly to Kinesis, or you can dump them into S3 for later. We tie in with X-Ray, which allows you to do you're building a distributed system, so you get a look at what does that picture look, how's that data flowing. And finally, also with CloudWatch, so you can look for errors, you can use insights to get a story of what your architecture is doing. As for targets, you can use AWS services, you can point to external services, anything that's an API, right? You can look on-premise through like a direct connect, and you can look at like private endpoints inside of your VPC. So there's a lot of flexibility on what you can do. However, we know that a lot of customers are saying, look, that's just my front. The front door is very important, but I'm not using all those other features. And so API Gateway becomes pretty expensive for just proxying maybe a Lambda or something like that. So in reInvent 2019 and GA earlier this year, we released HTTP API. And the benefits of that is it's 70% lower cost, 50% lower latency, and it's easier to use by far. And it offers features like throttling, OIDC and OAuth 2 authentications and things like that. And we are working to make feature parity between a REST API and the HTTP API so that you can continue to take advantage of the features and benefits through HTTP API. So let's talk about events. We've talked about the APIs. With events, they allow for decoupled services, and events aren't new. Events have been around, enterprise message buses have been around since the late 80s or early 90s, and they allow businesses to loosely couple services that are often changing. A lot of businesses will grow through acquisition, so the services they're using are different. So by communicating through events and triggering off that, they're able to loosely couple those and keep their systems up and running, right? And so today at AWS, we think of serverless applications as being comprised of decoupled services that scale independently and trigger execution using events. And we've built a lot of services to take advantage of this pattern, from streams like Kinesis and DynamoDB to events, any number of external services or internal services. We built features into them like retry logic, successive failure handling, and different things like that. And the services can be coupled together. So when we build services like Kinesis or DynamoDB or API Gateway or Lambda or step functions and on and on and on, we can then glue them together to build full applications. And we've really felt this is meeting the needs of old world enterprise business to real world IoT to modern mobile and decoupled applications. So we talked about gluing them together and kind of gluing these services together to work. Let's look at how that's done. And there's several different patterns. The first are queues, which we use Amazon Simple Queue Service. And with this, we've also just added the first in, first out. So there's ordering that can be done with this. You can also do pub sub, so publication subscription, with Amazon Simple Notification Service, or SNS, to which we, in reInvent, we released DLQ for this. And finally, with Event Bus, with Amazon Event Bridge Service. The Amazon Event Bridge Service, we really doubled down on CloudWatch events. We see events as the core way of building serverless applications. And not only can you use them with internal services, but also we're adding external third-party SaaS providers to provide events in that work in the same pattern that you're already using internally. We've already got a lot of partners like Mongo or Zendesk or Datadog or Auth0, and many more are coming. But when developing with events, you need a way to publish events, which we've already talked about, events coming in through third party or through our own systems. But you also need a way to consume them, and you need to consume them consistently. With traditional APIs, you work with a type rather than a string or JSON that needs to be parsed. So we created the Event Bridge Schema Registry, and we wanted to give you something, or we wanted you to have the same strongly typed objects available that you have in traditional APIs. So let me show you an example of how this works. Here's my event bridge, and events are coming in, and I have a schema already for a sales. But as a new one comes in, it's identified and it creates a new schema called the refund schema. And you can see events coming in, and my code divides them out based on that strongly typed information. And this same pattern happens. You can see the ticket schema was created. So now I can code based on that. So as events come in, I can route them based on their types, and I have a lot of control over those. The last pattern that we see is that of data streams. So with data streams, you have Amazon Kinesis data streams, which is great for ingesting vast amount of information. All right, so I want to get a lot of information. I want to get it fast. You have that, and then also it's great for ordering. So ordering for first in, first out. And then we also have DynamoDB, which is your data store, but it also has streams off the back. But what if you can't use DynamoDB? What if you are using you need relational database with Lambda? And that's kind of hard because of the ephemeral nature of Lambda. Your connection can go away, and it's kind of hard to manage that connection. So in light of that, we created RDS Proxy. And we think of this as two sides, right? So you have your proxy to your DB, and then you have Lambda to proxy. And you can create the password at the proxy that talks to the DB, and that your database administrator can maintain. And your Lambdas don't need to know that password. All they need is they're going to use identity and access management to access the proxy. And so that can be built into the logic with the Lambdas. So this allows you to be more secure and isolate that security based on which roles are being handled. The second thing it improves is it allows Lambda to scale massively as Lambda does, but not worry about managing connections because they can reuse the connections that are pulled by the DB proxy. So even with these three patterns, we know that there needs to be coordination. And we want to help developers remove this coordination code from their code itself and move it into services. And many customers use step functions. Now, standard step functions can run for up to a year. They have a strong exactly once guarantees, but we know that they're kind of over-engineered for maybe some more ephemeral and quick process jobs, right? So we also came out with express workflows, which are ephemeral and paired with Lambda type workloads. You can get 100,000 streams per second. They're shorter in duration. They provide at least once rather than exactly once on action, and they can work in conjunction with the standard workflows as well. So we've covered a lot, and you're probably here because you are considering future plans and you're validating ideas that you have, and teams are looking to adopt serverless programming model. They look at it in different ways and they approach it in different ways. First of all, organically, we have a lot of customers that will start with IT automation, and then they'll move into data transformation, maybe some transforming data dropped into a bucket, and then they'll move to business critical applications. The second way we do is serverless first, where people say, look, we're going to try to build it first in serverless, then if we can't, we'll move somewhere else. And with that, they get rapid development, they get time to market is decreased, their agility is increased, and they're able to deal with changing businesses, right? So I encourage you, as you're looking at this, if you're looking to deliver innovation, I encourage you to ask yourself, what approaches can we take to get the most agility? Let us handle the elasticity. Let us take care of that. And you take advantage of the total cost of efficiency. Going forward, I encourage you to take advantage of our training classes. We have live instructor-led courses with accredited AWS instructors. You can see the link here at aws.amazon.com/training/path developing. And with that, I challenge you to go and build. Again, my name is Eric Johnson. You can find me at EDJ Geek on Twitter. Glad to answer any questions. Thank you. I hope you enjoy the summit.